In this lesson, we will be looking at functions and relations, as well as evaluating functions for different values of x. So let's review. What is a function? Remember that a function is a rule that associates each x value to a unique y value. Notice the example here on the right. The first one is a function. For every x value, there is only one y value. Notice the bottom one. This is not a function. We have an x value of 1, and it has two different y values, 2 and 4. Therefore, it is not a function. One way we can check to see if something is a function is by using the vertical line test. This works well when we have graphs. A vertical line intersects the graph in at most one point. If it passes that, then it is indeed a function. Look at this first graph. I've drawn a red vertical line through. Notice that it only intersects the graph here at one point, nowhere else. In that case, this is, in fact, a function. It's a linear function. Look at the graph to the right. This red line intersects the graph in two locations. So in other words, whatever this x value is out here, we have two different y values, just like this up here. In this case, this is not a function. One thing to keep in mind, though, is that we do work with many equations that are not functions. When we work with the inverse of different types of equations, a lot of times those are not actually functions, but we still work with them. Let's move on. Evaluate a graph of a function. Okay, this is just to help you understand function notation and make sure you remember how to do this. So let's look at this first one. This is f of 3. So we are trying to evaluate the y value when x is 3. So on our graph, we go to where x is 3, and we look up here, and we can see that the y value is in fact 4. So f of 3 is equal to 4 on this sinusoidal function. Let's go ahead and look at the second one. Pause the video and think about this one. It's a little bit tricky, but see what you can come up with. Okay, well, very simply, if you go to f of 6, where x is equal to 6, the y value right here is going to be 0. However, if you'll notice this sinusoidal function, this goes up, it comes down, it goes up, it has a repeating pattern. So do we have other values that are equal to f of x, or f of 6? Well, in fact, we do. If you look at right here, where in this case x is 0, our y value is also going to be 0. And if you scan, noticing this pattern, we have another value here where f of 12 is also equal to 0. So assuming that this function will end where this picture is on either side, we could also say that f of 6 is equal to f of 0, which is equal to f of 12. And we'll be exploring more with domain when we have repeating patterns and functions like this sinusoidal function here. What happens now if we have two functions? So we have f of x and then we have g of x. They intersect in multiple locations, but let's go ahead and do some evaluation. So what's f of 5? Well, we can figure out f of 5. It's right here. It's 3. But again, think about this. Pause the video. Is this also equal to something else? Well, if you think about it, there's another function there that has a value of 3, and that is g of x. So when x is 5, y is 3 in our function g of x. So we can also say that f of 5, not only does it equal 3, but in this case it equals our second function, g of x. Okay, another thing to think about. Pause the video and try B. When will g of x be less than f of 5? All right, well, let's go to where f of 5 is. Well, here's x, and f of 5 is here. The value is 3. So we're asking ourselves, when will this function have a value that is less than 3 for y? Well, we know that it will when all the x's are less than 5. And if you'll notice here, because this is a linear function, if we head to the left, we will always be less than 3, which is what f of 5 is equal to. So when x is less than 5, we will always have a y value that's less than 3. Let's move on to a different type of evaluation. Let's just look at our functions, our algebraic functions. Let's evaluate a function. Here we have x squared plus 2x, and we want to evaluate it for f of 4. How do we do that? Well, hopefully you remember that we just take 4 and we substitute it in for x. So let's go ahead and do that. Once we replace x with 4, we have this. We can now simplify by taking 4 squared to get 16 plus 4 times 2, which is 8, and that gives us 24. Well, let's keep going. What happens if we have this? F of negative x. Think about this for a minute, and then see if you can get the same answer that we'll get together. Well, what does this mean? This means that in place of x, we want to put a negative x. So we're going to have negative x here, and notice I'm putting this in parentheses. If I didn't, that negative would be outside away from the x, and I would square the x first and then multiply by the negative. So because we want x to be negative, I need to put this in parentheses. Plus 2 times negative x. Let's simplify this. Anytime you have a negative number that's squared, you will get a positive number. So we can rewrite this as x squared. 2 times the negative number will get us a negative. So we can write this as negative 2x. Let's look at c. This is a little bit different. The negative is in front. Well, remember what f of x really is. It's just y. So what we're saying now, compared to b, we wanted a negative x. For c, we want a negative y. So we can write it like this. Negative y is equal to x squared plus 2x. Now we always need to simplify. We have a negative y. How do we remove the negative, or how do we get rid of it? We can either multiply through by a negative 1, or we can divide through by a negative 1. Either way, we end up with a positive y, which will be equal to, in this case, negative x squared plus 2x. Multiplying that through, we would get negative x squared minus 2x. Notice this is very similar to b, but the negative is not with the x, it's in front. So if, for example, the x was 3, we could square it to get 9, but then we would put the negative back out in front for negative 9x. All right, last one. In this case, we want to substitute all the x's for x plus 1. So we would have an x plus 1, we would square that, plus 2 times x plus 1. So in all these cases, I have replaced x with whatever the problem has asked me to replace it with. Now I'm going to simplify. Well, we have a binomial squared. Remember there we have a pattern. We can either take x plus 1 times x plus 1 and distribute, or we can use our pattern. Take the first term squared, multiply the first term times the second term, then times 2, so that would be 2x, and then square the last term, we would get 1. For this last part, we distribute the 2 into the parentheses to get 2x plus 2. Now we're ready to combine like terms, and we end up with x squared plus 4x plus 3. And that is how we evaluate functions given a value.